Hey guys, welcome back to the channel. Today we're going to be creating Onshape Advanced Isometric Lab number 2. So let's go. Take a look in the Google Classroom at Advanced Isometric Lab number 2, and you should see this image that shows up in the Google Docs. Taking a quick look at this image, what we want to do is break down what's the easiest way to create this block. Looking at these angle pieces, we can create these while creating the sketch, or we can flatten these off and make them all perpendicular and then use the chamfer tool to cut those angles in. I'm going to get you a little bit more familiar with the chamfer tool. So we'll be making this object as a straight line perpendicular shape first, then cutting these angles in using the chamfer tool. Removing this top section to start with allows me to create this base part without the need for adding this top yet. We'll add that in as a secondary feature. So let's take a look at how I would create this base. Starting a sketch from the top view, I would begin in the upper left-hand corner and draw a line straight down 16 inches and then perpendicular to the right 12 inches. So let's go in and get that started, and then we'll see how we can follow along with this to create the bottom shape. In Onshape, under the Documents tab, click Create a new document, and call this Advanced ISO number 2. Once your screen is loaded, you want to create a new sketch plane on the top plane. But before I do that, I like to get rid of any other planes that I'm not going to be using to start my object. This just helps clean up the area and makes it a little less cluttered. Now I'll use the sketch tool to create a sketch on the top plane. I'm going to click on the top of my Cartesian cube and rotate this perpendicular to my line of sight. This is going to help me in creating the image that I want. Back in the Google Doc, I want to confirm the dimensions that I need in order to start this part. As I said, I'm beginning in the upper left-hand corner of my object, and I'm coming down 16 and then perpendicular 12. So that's where I'll start this drawing. Using a straight line tool, I'm going to begin near the top of my screen and just draw a line straight down. You'll notice the dimensions are way shorter than they need to be, but that's okay. We're going to use the dimension tool to change that. Switching to the dimension tool, I want to add a 16-inch dimension to this vertical line. You'll see that the line gets much larger. That's okay. If we click on the top of our Cartesian cube, we can zoom out to see both ends of it. I like to zoom out a little bit more just to make sure that I have enough space down here to be able to click on the correct endpoints. The next thing I'm going to do is create another line from the bottom of the first line perpendicular to the right. Use the dimension tool to make this line length 12 inches. Again, I'm going to zoom out slightly here just so I can make sure that I have enough room to begin drawing downward from the endpoint of my 12-inch line. Back in the Google Doc, I want to reference now. How far is it from the horizontal 12-inch line all the way down to the front face of my object? Well, there is no exact dimension given right in this area, but if I use associative dimensioning, I can look across the object and see that from this face, which is parallel to my 12-inch face, to the front edge of my object is 16 inches. So that's going to be the next line I draw here, 16 inches from the endpoint of the 12-inch line down. Using the straight line tool, connect to the endpoint of your 12-inch line and begin drawing straight down. You can end it anywhere and use the dimension tool to apply the 16-inch dimension to this vertical line. Again, clicking the top of my Cartesian cube gets us zoomed out a little bit and in a good position to begin continuing this object to the right. Now that I've created that line, I want to double check and see how far is it going to be from where my line just terminated, keeping in mind that I did not draw a diagonal. That line, 12-inch line, went straight down. If the distance between the existing object and the left face of the existing object is 18 inches, but I didn't draw it on a diagonal, I have to take the 18-inch distance and subtract 12 to determine how much I have to add to my 20. Let's review that again. I'm currently sitting in this corner position, drawing a vertical line straight down. That vertical line now has a distance between where it ended and where my 20 is going to begin for this front face dimension. So I have to take the 18-inch dimension from 20 to left face and subtract 12 from it. That's going to give me the distance I have to add to this line in order to go all the way across the front face. Luckily, our object is symmetrical, so I'm actually going to add that distance that I come up with to the right side of this as well. 18 minus 12 gives us 6. So if I have 20 and I add 6 to both sides, I should end up with 32. Let's now create a line length from the bottom point of our 16-inch line horizontal to the right and give that a dimension of 32. Don't forget, you can also use equation dimensioning. If I'm not sure exactly how to run those numbers, I can always say, take 20, use the plus symbol to add 6, and the plus symbol again to add 6 more. That will, in turn, also give us the answer of 32. As I said before, the object is symmetrical. So what I did on the left-hand side, I can repeat over here on the right-hand side. Now that I've gotten to my 6-inch mark, I can begin on the endpoint of my 32-inch line and draw vertical. This line is going to be given the exact same distance as the line parallel to it on the left, 16. I can then draw a horizontal line from the endpoint of my new 16-inch line going out to the right, and I can make this line 12 inches. I can also finish the right side of this object by drawing another vertical line straight up, being careful not to lock it into any kind of snap points on my shape. And I can give that a dimension of 16. The last line will be pretty simple. It's just connect the dots. Let's create a straight line from the top of my right 16-inch endpoint to the top of my left 16-inch endpoint. And now my object is created. If I rotate this isometrically and then finish the sketch and choose the extrusion tool, I can now extrude this shape the height that it's indicated in the Google Doc, which for us is 8 inches. So I'm going to extrude this a height of 8. Once I've completed that, I can now go in and chamfer the necessary corners in order to get my object to look more like it does in my Google Doc. The distances we're going to need to know for these chamfers are 16, which is its vertical length, and 6, which is going to be its horizontal length. Now that I know 16 and 6 are the line lengths I need to use in order to cut this angle onto a diagonal, I'm going to select the chamfer tool, use 2 distances in my menu, and change the distances to 6 and 16. Clicking on the edge of the line area. Now that I know the distances I want, I can use the chamfer tool and change the chamfer menu to a 2 distance option. The distances for my lines are going to be 16 and 6. 16 for distance 1, 6 for distance 2. Now I can go and click on the edge of the corner point where I need to remove the material. Remember, this is a symmetrical object, so I'm going to click on both the front right edge and the front left edge. Double checking my Google Doc should verify that the 6-inch linear dimension was across the face and the 16-inch dimension was along the top of the object. I can verify that by just visually looking at my part. And now that I'm completed with it, I can hit enter. And I've got the 2 cutouts that I need in order to complete the base of my object. The next thing we're going to do is add that top section. The top section is going to be perfectly centered on our existing object. So what we're going to do is this. We are going to break this object into 2 pieces by cutting it straight down the middle. I'm going to create a right side of the object and a left side of the object, both being half the width of the full width of the object. In this case, the full width of our part is 8 inches. So each individual rectangle is going to be 4 inches. They're also going to be 24 inches in length. So let's go now and create a sketch plane on the top of the existing shape and create the space we need for that secondary part. Select the sketch tool from the ribbon, click on the top of our existing object. Using the top isometric cube option, we can rotate this to look straight onto the top of our object. Now I'm going to use a rectangle tool. And what I'm going to do is hover along the top of my object until I snap to the center point. Once I've snapped to the center point of my back line, I'm going to draw a rectangle down and to the right, and then repeat that step by snapping to the center of my top line and drawing a rectangle down and to the left. Keeping in mind, I didn't try to make these the exact distances because I'm going to use the dimension tool to do that. Now that I've got my two geometric shapes, I'm going to select the dimension tool, create a dimension for the vertical height from our top view, which is 24 inches for both my rectangles, and then create a horizontal distance that's equal to half the full object width, which in this case is going to be 4 inches for both rectangles. Now that I've created the profile, I'm going to finish this and then extrude it. Changing back to isometric view will allow me to see the direction in which I'm about to extrude. Selecting the extrude tool and then choosing both rectangles, I can see that my object's going to extrude vertically, but I need to know how tall exactly. So back on the Google Doc, I'm going to take a look at the height dimension that's been given to our object. The height of the object is 16 inches. So my extrusion dimension is going to be 16. Click the check mark to finish off that object, and we're one step away from completion. The last thing we have to do is cut this chamfer through the object, but I need to know the chamfer lengths. 24 inches is the full length of the object, but then as it tapers up, the remaining distance is 14 inches to the back side. 24 minus 14 tells me that the object that's been removed was a 10-inch line. It's also going to be 16 inches in height. So now let's go in and try using the chamfer tool to apply that 16 and 10-inch chamfer. Selecting the chamfer tool, I want to change to two distances. The distances I'm going to use are 10 inches for distance 1 and 16 inches for distance 2. Selecting the very top edge of my existing part where I want the material to be removed. Selecting the chamfer tool, I can change my chamfer menu to two distances. The distances I want to apply here are 16 inches for the height, distance 1, and 10 inches for the depth, distance 2. Select the top edge of the object where I want my diagonal to cut through. As long as it's gone 10 inches along the top and 16 inches down, which it does appear that ours has, double checking the Google Doc, I can verify that. I can click the check mark and my object is now complete. Once you've completed this object, don't forget to share this with me. This is advanced ISO number 2. First of two parts of this activity. The second part is going to be creating the drawing sheet that we're going to review in class. Thanks for watching, guys.